This is part 4 of sequence and series, and we're going to look at finding the sum of an arithmetic series. Well, here we go. We've got a series. The question is, what's the sum of the first 20 terms if this is the sequence, 2 plus 5 plus 8? Well, and it keeps on going. What's the, how do we figure out adding 20 of these terms? Well, A is 2, because that's the first term. 5 minus 2 is 3. The common difference is 3, and there's 20 terms. Well, this is one formula you can use. N over 2 times 2A plus N minus 1 times D. There's one where you go the first term plus the last term. That's what this contains right here, really. But let's just put 20 in for N, 2 in for 2, 20 in for N again, and 3 in for D. And there we're going to get our answer. 2 times 2 is 4, 19 times 3 is 27, 4 plus 57 is 61 times 10 is 610. So the sum of these 20 numbers, 2 plus 5 plus 8 plus 11, all the way 20 of them is 610. Okay, let's take a look at the next question. What if you've got, it says determine the sum of the following series, 2 plus 5 plus 8 up to 32. What's the sum of this? But we don't know how many terms there are. So that's what we've got to think. We first need to determine how many terms are in the arithmetic progression here in the sequence. So what you do is you know that Tn is 32, you know that A is 2, and you know that the common difference is 3. So what you can do is write down the formula Tn equals A plus M minus 1 times D, and fill in all the stuff you know, that D is 3, that A is 2, that the last term, whatever it is, Tn, the last term is 32. So now we just have to solve this equation. We go 3 times n is 3n, 3 times minus 1 is minus 3. We take away 2 and get 30. We add 3 and we get 3n equals 33. Add 3 to both sides. We don't do these things to both sides. We divide both sides by 3 and we get, hey, there's 11 terms in here. N equals 11. Now we need to find the sum of 11 terms. Like I said, there were two formulas. There's this one with 2a plus m minus 1 times d, and there's one that just says the first term plus the last term. Well, here's the easiest one. To find the sum of the 11 terms, we just go 11 over 2 times the first term is 2, and the last term is 32. So 34 divided by 2 is 17. 11 times 17 is 187. You can use this formula and substitute in A and D and N, and you'll get the same answer. I won't go through it all, but you just get the same answer for the sum of what we know is 11 terms. Now here's a question that's a little bit more challenging, I think, here. How many terms are in the arithmetic series 34 plus 40 plus 46 so that it will sum? So that the sum of this arithmetic series is 1,530. Well, we know the sum of the term is 1530. We know the first term is 34. We can see the common difference. It's going up by 6. 40 minus 34 is 6. The question is, let's figure out n. Well, let's see what Mr. Autry did. He just put in 1530 here. We don't know what n is, but we know A is 34, and we know D is 6. Now we just got to solve this thing. 2 times 34 is 68. 6 times n, 6 times minus 1. 68 minus 6 is 60n, okay? Or sorry, is 60, okay? And we've got 60 plus 6n. Well, 6n times, 68 minus 6 is 62. That's why he's got 62 here. And 62 times n gives me 62n. 6n times n is 6n squared. Now we subtract 3,060 from both sides. We get this quadratic equation. Always look for a number that will go into both, to everything. And it looks like we could divide everything by 2. 6 divided by 2 is 3. 62 divided by 2 is 31. 3,060 cut in half divided by 2 is 1,530. Now you probably don't know your times tables up to 1,530, so you're going to have trouble factoring this. If you put this in the quadratic formula, that negative b plus or minus the square root of b squared minus 4ac, your calculator will give you two answers. One will be 18, and the other will be minus 18 over 3. Well, the only one that makes sense in an arithmetic series for n's got to be an integer. So n must be 18. So just use the quadratic formula here, and you'll find that n is 18. It's pretty hard to figure out that 18 times 85 is 1530. It's always good to go to the quadratic formula when you have these big giant numbers. I hope this helped.